All right, so small language models. I'm going to talk about small language models. It's going to be kind of a very two-stage talk. So that's the first thing. The first part is going to be about the business part. So if you're from the tech side, please, sorry, I might bore you a bit. The second part is going to be a bit more techy, not as techy as I wanted it to be, but let's see how far we can go. In terms of timing, I usually talk until I get stopped, so tell me if I run out of time or something. Yeah, 20 minutes. I haven't rehearsed or anything, so just tell me. All right, a bit about my background. So I started as a backend engineer, a bit of ML there. I did a bit of like analytics, data science. Previously, I was Procter & Gamble. I was a AI engineering manager. Now I'm at We Build AI. I don't think there's a question on what we do, but yeah, so I'm working there. So first part is going to be about the business things. So first thing first, your model doesn't need to be very big. I think this is something that the Anthropic CEO, Dario, his last name I forgot, Monday, yeah, he was saying like if you have a small task, don't give it to like the biggest model that you can find. Give it to a smaller model. It can do it. So it could be just the right size, and that's very important. That's probably if you want to have one takeaway from this talk, that's what it needs to be. You don't need the biggest model for everything. Just the right size of model can do what you want. So what is a small language model? That's probably the first thing. So any model, I'd say, that you can run in a device that you can see and it's not in like a big infra is a small language model. Though you could run your model in a data center in like AWS or any other places, you could run it there, but still any model that you can fit in like a normal machine could be a small language model. Though people might agree or disagree, there are some, like I do have a chart in the next slide, but yeah, so somewhere along the way there. So we got like really, really small language models, less than 1 billion parameters. It's like super, super small. It can do a ton of cool things. Like we got Tiny Llama, pretty cool to be honest. It can still do a lot of things. You'll be surprised. Somewhere between 1 to 7 billion. We got, again, really, really good models. There's like DeepSeek, 7 billion. It can do a ton of cool things. 7 to 13 million. I can still run like a 13 billion model on my MacBook very easily. It can handle that. You got larger ones, 13 to 30. I have tried like maybe a 30 billion model on a Mac Mini, and it can run just fine. So yeah. It's just infra. You can run it on your MacBook. You can run it on your even MacBook Air, on a Mac Mini. Pretty cool shit. Sorry. So if it fits on your laptop, if it doesn't fit on your laptop, it's not that small. That again, another takeaway. Me just now. So there are three reasons why you should do this, and this is very important. Again, a lot of people might say, "Oh, why should I do this when there's like a big model right now available to me at like X amount of dollars per token? It's super cheap." The big three reasons. One is that your data stays at home. So this is super, super important. Things like GDPR, things like how is the data processed? Does it go outside UK or US, wherever you are working at? Does it leave that continent, that country? How does it get processed? This is super, super important. If you're working in a highly regulated area, this might be super, super important for you. The next thing is auditable and traceability. So again, for me, this second guy is kind of me. Like I have some local language models that run on my MacBook. I can put my credit card number, my whatever, anything I want, my passwords, whatever. I don't really need to worry about that. So that's really cool. Your data gets processed there on your CPU. It doesn't even leave your network, your computer. That's pretty nice. You can do the same with like any other model. If you are, again, within an Azure or like AWS network that you don't want the model to leave that infrastructure, that region, you can do that. So it really helps in that case. So right now, when you're calling OpenAI or Anthropic or any other provider, your data goes through the internet, it goes there, it gets processed through maybe thousands of machines because it's distributed, and then it comes back to your machine. So there are some privacy issues there. Again, putting my tinfoil hat on there. If you have some sensitive data, that could be a cool thing to do. And then again, it's cheaper. There's a caveat here. You could say that still some of these language models that are being provided are still cheap, but to be fair, right now VCs are paying for it. Venture capitals are paying for it mostly. In the near future, the cost might go high. What we saw with GitHub pricing, it was changed. A lot of things might change in the future. So again, if you have a high usage, even with your normal cloud code, you might run out of tokens. So you have like a window that you can use, and then you might run out of tokens. So again, this you can run as much as you want, as much as your GPU on your MacBook or your Mac Mini or your computer can handle. You can run it. So your device, you can use it as much as you want. So that's good. So in general, cage match, in terms of cost, as I mentioned, like it would be cheaper. And as we go further and further and further, it would be cheaper. So it's nice. In terms of latency, again, it doesn't hop through different networks. It doesn't go to the other side of the ocean. It doesn't travel different parts of the world to like return something. So it literally goes within your different chips within your computer. Pretty cool. Hardware, in terms of hardware, you can run it on a potato. Like really, even with those small models that I mentioned, like 1 billion, you could run it on a technically Raspberry Pi. So that's really cool. Like imagining that, like 5 years ago, 6 years ago, that was not possible. So right now, having that, it's pretty cool. You can do a lot of things that you want to do. In terms of like privacy, again, as I mentioned, like you have full privacy. All the chats are on your machine, on the machines that you own. Again, be that even in a data center. So that's what I'm trying to say. Even if your machine that you're running it on is on AWS, is on Azure, is on a data center, but still it's your machine. When you're making an inference, it only gets processed there. So you can delete it. No one is going to train on your data. You can send whatever you want. You can delete whenever you want. You're sure that it's going to get deleted. So more or less, it's much better. And then in terms of customizing, and that's something that the second part of my talk is going to be about, how you customize this, how you fine-tune this, because best for. So this is the part, those large language models are really, really, really good at general tasks. Whatever you throw at them, they can search, they can do a lot of things, and they're trained at, they train on a ton of data, so they can gather all this information that they want, and they can do what you ask them. But smaller language models might sometimes, they might not be able to answer what you ask them. So what you probably sometimes need to do is to fine-tune them, change some stuff, and we talk about it, but if you really want good output from them, that fine-tuning part might be something that you want to look at. And by the way, if you have any questions, just feel free to interrupt. That's all good for me. So this is also something, since 2023, every meeting you go, some executive is going to tell you, we need Gen AI for this, Gen AI for that, agent for this, agent for that. Everything is about that, even if you're doing something like classifying emails, like something as simple as that. I've been there, I got requests like this. Oh, this is something simple. We've been doing this with like a naive Bayes classifier. But no, we need Gen AI for this. So again, if you really want to do that, you could still do with a small language model. That's also something cool. And I hope you get the Monty Python reference. So part 2. How am I doing with time? All good? All right. So part 2, my interesting part. So yeah, nerd alert. So there are generally 3 types of like methods that we do when we're dealing with small language models. They don't do the same thing, but well, the first two do the same thing, but the last one is more like fine-tuning. But I put them back to back because they're kind of the same topic because they deal with small language models. Now, quantization. So quantization is basically, I go into details, but like basically what we do with quantization is that we take the language model when we have a binary floating point 64 or like a large like floating point there, we want to decrease the accuracy intentionally, because when you have like a binary floating point 64, it has like 64 bits of data, whatever, you have a lot of information there. Sometimes we say it might not be that much useful, so you can reduce it to an integer. You might introduce decrease it to like a floating point 16 or something like that, and that doesn't really decrease it, accuracy. And that's something really cool. The other thing is distillation. Basically, with distillation is that we have a teacher model, a really, really large language model, and then we want to give the output of that large language model to a smaller language model. And it shows that that large language model can teach the smaller language model, and the small language model, even though it is super, super tiny, it can still work well. Pretty cool, pretty cool. And lastly is LoRA, low rank adaptation. It's mainly a method to direct small language models to do certain things. So you have a small language model, you want it to do something more than what it was trained for, so you can use LoRA. So we go through all of these. First, as I mentioned, quantization. So you got a floating point. You have a large language model with like 30 billion parameters. It's huge. There's like it requires a huge amount of memory to process the data. What you need to do is that, or what you can do basically, is that you can move to like a floating point 16 or integer, or even an int 4, or sometimes even like they go with int 1, like very, very small. That's a bit like too much, but like even with int 4, you get really, really good results. So it's pretty cool, honestly. It shows that not all of those accuracies that we were looking at with a floating point 64 might be needed. So if you still have the same model with smaller floating point, or even with an integer, still works. So that's very interesting. So again, you go with an int 8, your cost goes like much lower. And if you use some caching, so KV caching is key value caching, and speculative decoding. Speculative decoding is that still when you have like a 7 billion model, you can use like a much smaller model, like a 1 billion model, that it can produce some of the tokens that you want, and then you can use that for the larger model. There's a lot of like hacks there that they do, really like touching the surface there. But doing all of this together, you can have like a really, really fast small language model. And the cool thing is that quantization can also be used with distillation. So they don't have to necessarily be like separated things. So a lot of the small language models that you get from Hugging Face or other places, they are actually both quantized and distilled. So they can be combined. That's also another thing. Now, what is distillation? As I mentioned, you get a big language model, and then you get the outputs of that large language model. You teach a smaller language model to behave like that. So that's basically the same, it behaves the same as that large language model. When we talk about like we get the outputs, it's not only like the sentences, it's mostly the distribution of the outputs. So just talking about how language models work, very, very, like again, touching the surface. When you have a large language model, or any language model, basically, the output is a softmax usually. And that softmax, with the size of your vocabulary, that could be 50,000, 70,000, or as large as you want, it has like a huge number of vocabulary. That softmax will tell you like what could be the next word. And then when we want to generate, we basically take, sometimes as a greedy way, we take the first pick, and then the first pick, and then the first pick. But that's not how it happens. Sometimes we use like something like beam search. So we go through like the second or the third or fifth options, and then go through that path to find the best generation. So that's how we do it. Now, if you get this distribution, not this one that you get like, oh, it's definitely a cat, but you give this distribution like a soft max of all the options that you have, and you give it to a small language model, you teach it based on that, that small language model usually learns to behave like a large language model, and it works again like a miracle. It's pretty cool. So lastly, LoRA. LoRA or low-rank adaptation is a method for fine-tuning. So when we talk about fine-tuning large language models, it's really, really expensive. So it takes a lot of like GPU power. You can't really do that. Even taking like the last layers, if you want to, let's say, fine-tune the last 5 layers or 2 layers for something, it usually takes a huge amount of GPU power. Probably most of us in this room don't have access to that. It takes like millions of dollars. So what you can do sometimes is that you can take your small language model, and then even a 7 billion model still takes a lot of money to fine tune. So you can take that, you can add a couple of low rank matrices at the end, and then you can fine tune those. So that's basically the, again, very, very small idea about it. There are a lot of hacks there. There are a lot of methods there that people have been using. A lot of like variations of this that exist. But yeah, that's the idea. You fine tune only those last parts. And then what that gives you is that you can instruct your model to behave in a different manner. Like usually, for example, if you want your model to speak only in formal way, you can just give your model instructions as a like system message that, hey, always behave this way. But if you really want your model to always ask in question forms, so you can fine tune it like this, and your model would never ignore those instructions. So that again comes back to that privacy and all of these things that we talked about, right? So you want your model to never, ever, ever do something, you can do this, and like really stick this in your model that never, ever, ever do that. So those attacks that usually happen with like prompt injection and other things are less likely to happen. So yeah, and then you usually train very few number of parameters. It's way less. I've done it on my MacBook Pro. It's much simpler. So you get like a 7 billion model. You can add like a few LoRA layers, like 2, 3, something like that. And then you can get some training data. If it's like a chat model or a question and answer model, you can generate, steal, download, whatever. Get your data there, and then fine-tune your model based on that. And there are libraries available for that, super simple. All you need to do is just a couple of commands there, and it works perfectly. And then once you did that, you can actually, again, do some of those like quantization or distillation, not much, but quantization, you can do that. So again, if you want to get that model, make it even smaller, you could do that theoretically. So you want to run a model on edge, like edge devices, like with very low amount of memory. You could take a 7 billion model that was distilled originally. You can add LoRA and like other stuff. You can fine tune it, and then you can take that and then again quantize it and then run it in a smaller, low power device. And that would be your model. It does what you fine tune this model, and it would behave the way that you want it. So yeah, again, it would be like a post-it note. So I put it here, I think, yeah. So I think this shows it pretty well, because if you think your LLM is like a huge thing there, LoRA is like a small part here. But again, it would really, because it's the last layer, usually the last layers determine a lot more in like how the model behaves. So it would really, really helps how the model behaves. So you can, again, make your model behave in a certain way. But again, it might break as well. So again, you have 3 ways. So you can shrink your model, you can quantize it, as I mentioned, from floating point 64 or binary floating point. With modern GPUs, you have like binary floating point. It's much better, whatever. So you can quantize it. You can distill your model. You can do a combination of these two. A lot of the models that you get from Hugging Face, you download from community like, again, DeepSeek 7 billion. These are all quantized and distilled together. So they've done all of the work for you. And then you can adapt it based on what you need. So all of this together will give you like a small language model that you can run it in a small computer. You can make it behave the way that you want. And then you can run it in the infra that you choose, and you want to like fence around it so that no one can access it, so it's privacy preserved. I think that's all. Yep. So yeah, and also I'm hiring. So if you have any, if you want to do these cool things or make these type of slides, yeah, I'm here. How did I do? Yeah, good. All right. Questions?